Hello everyone. So today let's solve the problem 9.1 decode with. So let's see what the question states here. We have intercepted a secret message encoded as a string of numbers, right? So the message is decoded via the following mapping. See, 1 is mapped to A, 2 is mapped to B, and this one 25 is mapped to Y, and this one Z. So same goes with the other letters as well. So see here, 1A, this one 2B, and like 3C and 4D, like that it follows, right? So this will be finally, they have given here 25Y and 26Z. So we have 26 letters, so 26 will be equivalent to Z, right? So let me delete this one. Now, however, while decoding the message, we realize that there are many different ways we can decode the message because some codes are contained in other codes, right? So see here, uh, 2 and 5 versus 25 basically. We have got the same two numbers within the 25, right? So for example, 11106 can be decoded into double AJF with a grouping 11106. Also, we can just go with a 1110.6. So this one will be KJF, right? So this can also be done. They have given us wonderful example here, right? So the grouping 11106 is invalid because 06 is not valid code, right? So only 6 is valid here. Only 6 is valid, meaning so 0, there shouldn't be 0 at the beginning. That's what they're trying to say here, right? So there may be settings that impossible to there may be strings that are impossible to decode, right? So there might be some strings that are impossible to decode. That also they have given here. Given a string s, given a string s containing only digits here, we have to return the number of ways to decode the string, the particular string. If the entire string cannot be decoded into any valid way, in that case we have to return 0. The entire string that can't be decoded in any valid way, then we have to return 0. The test cases are generated so that the answer fits in the 32-bit integer. This is fine. See, now we have 12 and we go with a, right? So this one will be going with a B basically, right? So 12 could be decoded into A, B, or it is also this one. L is 12, right? So I can just go with 1A, this one 2B, 3C, like that. 12 will be, L will be equivalent to the number 12 basically. And we can just go with, we can just consider this one differently as well. So this one will be A and this one will be B basically. One is A and this one is B. So 12, we can just write it in this way as well, right? AB. So we can just decode in this way as well, right? So 12 can be decoded into AB or 12 can be decoded into L. Both are correct here, right? So this is fine, man. Yeah. Now let's go with the second example. Nothing but 226 they have given here. 226. This one. So here there are two ways, right? So we need to return the number of ways that it can be decoded. So here two ways. So we'll be returning 2 as output. So here we have 226. 226 can be decoded as see, 2 is nothing but B, B, B again. 6 is nothing but A, B, C, D, E, F. F is 6 basically, right? So this can be written as BBF, one thing, and it can be written as this one as well, BZ. So this one basically how it is busy. So here see, yep. So 226 can be considered as BBF, right? And one more thing, 226 can be considered as this one as well. B, 2 B is 2, right? So 26th alphabet is Z. So we can be this can be written like this as well, BZ, right? And also we can just go with here this one, VF. So we have 22nd word, nothing but V. 22nd letter, sorry, is nothing but V, and 6 is nothing but the F. So we can just go in this way as well, VF, right? So BZ, VF, as well as this one BBF, right? So 226 can be decoded into BBF or the BZ or VF. So total number of this thing decoding ways that we have here is 3. So we will return this 3 as the output, right? Let's move on with the final way here. Final one here, example 3, right? So here we have 06. So the numbers that is start, it cannot start from the 0 here. The numbers cannot start from the 0. This is one of the conditions they have, this is one of the criteria that they have mentioned in the question itself. So in this case, we'll directly return 0. So in the code, we'll directly return if the numbers, this one string starts from the 0, then we have to return 0. That is one of the criteria that we need to remember, right? So this is fine, I believe. They have given us wonderful examples just for the sake of understanding, right? Now, we are completely familiar with this one question as well as the this one input output, right? Now, let's discuss the approach followed by the complexities, and then let's write the code. First thing here, we will be making use of the DP to solve this particular problem, right? So we'll be going with a 1D DP to solve this particular problem, right? So first thing, first step here, DP of I here, DP of I is equivalent to the number of ways to decode the prefix, this one, from S of 0 to I minus 1. Just remember this one. DP of I is equivalent to the this one, number of ways to decode the prefix S of 0 to I minus 1. So this is easy, simple to understand. Now, initially, base case DP of 0, the first one, base case DP of 0 is equivalent to the 1. So this is for the empty string. This is for the empty string, right? So for each position I, the next step here, for each position I, let me go with for each position I here. So if single digit S of I is for all 1 to 9, we have to add, so this one, S of I to I minus 1 belongs to 1 to 9. Suppose for each position I, S of I can just write it in this way. This is just for the reference. Just listen to this carefully. So S of I minus 1 belongs to this one. What do we call 1 to 9? So this is positive. So let me write this one like this, right? So 1 to 9. So we have to add DP of I minus 1. So we have to add DP of I minus 1, right? In that case. So if two digits, if we have two digit, this is for the single digit basically. This is for the single digit. What if two digits, what if we are having two digits, right? So if two digits, so instead of S of I minus 1, we have to go with the S of I minus 2 to I minus 1, right? For the two digits. So this one has to be S of I minus 2 to I minus 1. S of I minus 2 to I minus 1. That belongs to this one. What do we call? Two digits in the sense two digits start from 10 basically, right? So 10 to 26, right? So this one from 10 to 26 positive. So I'm writing this on this way. So we have to add at that point of time, we have to add dp of I minus 2. At that time, we have to add dp of I minus 2, right? So this is simple, right? So let's consider the same thing. First example that they have given. In first example, they have given 12, right? So here, what we will do, the result is 2. The result is 2. Accordingly, with the approach that we have discussed now, result will be equivalent to 2. Why it is equivalent to 2? So 2, we can just decode this one here, this one AB for if this one, right? So we are going with a single digit, sorry, double digit for this one, 12. So we are just going with a this one. What do we call L directly? Or we can just for the single digit we can consider. For the single digit we can consider 1 and 2. So this one AB. For the double digit we can just go with the 12 directly and we can just give here L. So this can be decoded in the two ways. So here we will return 2. So we have got AB and L. The 12 can be decoded in the 12 can be decoded as AB and L. Basically, the count is two ways. We have the two ways to decode 12 AB and L. So this 2, we will return this one as the output. So the output that we have got here is 2, which is equivalent to the output that they have mentioned for the example, this one, which is equivalent to the example one's output, right? So that they have mentioned in the question. Now, so our approach works absolutely correct here. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would lead to big of n, right? So the time complexity would lead to big of n because we'll be going with a single pass through the string. So overall time complexity would lead to big of n. So what will be the space complexity here? The space complexity would lead to big of n as well for the DP array, right? The space complexity would lead to big of n as well for the DP array. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of n respectively. Now, as we are completely familiar with the approach and the complexities, let's start writing the code. First, let's go with the base case command. If the string is empty or if the string starts with 0, then there is no valid decoding. So this they have mentioned in the question itself. So I can just write it in this way. If s equals null or length of the s here, if it is equivalent to the value 0 or s dot char at initially, if it starts from the 0, right? So for the third example, you can look into the third example. It starts from 0, 0, 6 they have given, right? Then also, oh, this is within the strings, right? So I have to, yeah, for this particular one, I have to go with the strings, I believe. Yep. I'll just go with the, we have to return 0 in that case, right? So this is fine, simple one. Now, let's go with the initialization part. So let me initialize n to s dot length. So let me assign n to s dot length because we'll be making use of the s dot length many times within the code. So let me assign this one. This is nothing but the total length of the input one. Now, as we know that we'll be making use of the dynamic programming, let's initialize the DPR as well of size this one n plus 1. And also we have to go with the this one base case. DP of 0 is 1 and DP of 1 is 1. We know this one, right? So let me do that one. DP, sorry, so I should keep array here, int DP equals new int of n plus 1. This is fine. Yeah. So now DP of 0, let me assign this one to 1. Yeah. Next DP of 1, let's assign this one to the 1 as well. Now let's do one thing, man. Let's iterate over the prefix length here. So let me go with the for loop here. Int I equals to 2, I less than or equal to n. So this one will be I plus plus. So within the for loop, what shall we do? Let's check single digit decode. S of I minus 1. So this one will be char 1 equals S dot char at. So this one will be I minus 1, right? So I'll just go with the I minus 1. This is fine. Yeah. Now let's go with a single digit that must be non-zero, right? So if 1 not equal to 0 within the strings we have to give here, then we have to add the previous prefix base, right? So this one we have seen. So this one will be dp of I equals dp of I plus the previous one, right? So dp of I minus 1. Yeah, this is right. Next, yep, let's move on with the further things. We have to check 2-digit decode, right? So we have already checked for the single digit decode, nothing but s of I minus 1. So this we had discussed with the approach. The same thing we are implementing in the form of code here. Now we have to check 2-digit decode, nothing but s of I minus 2 to I minus 1. So I can just write it in this way. Into equals integer dot passant. So we're just passing. Yeah. So this one will be s dot passing into the integer basically, right? Number in simple terms. So I'll just go with a substring here. This one I minus 2 comma I. This is fine. Yeah. Now let's make use of the simple if conditions here. 2 greater than or equal to 10 and 2 this one less than or equal to 20, then dp of I equals dp of I minus 2, right? So this one we are just adding the prefix 2 steps back. Now, yeah, we are left with only one step, nothing but we have to return the final answer, nothing but all the valid ways, right? So this will be stored in the dp of n. So I'll just return here dp of n. Yeah, we are done with the coding part. So let me format the code once and let me hit the run button. So now this I has to be capital, man. This one I has to be capital. So this will be integer. So let me run the code again. Hope this works now. Again, we have the compiler error. So parse int here, this I has to be capital as well. Why? Get type capital, right? May run the code again. Mm, wrong answer. So output we are getting here as 1, but the expected is 3. Actually, yeah, there are 3 ways for the 2 to 6. We have discussed this one, right? What is wrong here? So yeah, what mistake I have done here is, so this is the reason it is showing 1. So see here, we have 26 here, right? So 26, I have given if 2 digits, right? If 2 greater than or equal to 10 and 2 less than or equal to 26, we have to consider. We have the 26 characters, right? 26 alphabets basically. 20 I have considered instead of the 26. So this is not considering Z as well as the VF. So now we have only this one. What do we call? BZ, right? That is the reason it is considering only one way, right? So this one it is considering actually, sorry, BBF is the one way that it is considering. So these two are not considered at all. Sorry, BZ and VF, because I have given less than or equal to 10, 20 instead of the 26, right? So now I've changed this one to 26. Let me hit the run button. Now this has to work. Yeah, now the sample test cases are getting passed. So let me hit the submit button quickly. So you can clearly see here all the test cases are getting passed. Means whatever the code that we have written works absolutely correct for all the test cases, right? I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.